So the first speaker is Dr. Meiyin Wu, and her presentation is Cyanobacteria Harmful Algal Bloom Management, Case Studies of Freshwater Systems in New Jersey. Dr. Wu is the director of the New Jersey Center for Water Science and Technology and professor of biology at Montclair State University. She is an aquatic ecologist whose research focuses on protecting water quality, sustaining water sustaining water resources, maintaining biodiversity, and restoring ecosystem functions and services. She has a wealth of information and always keeps me in line when it comes to QA/QC. And I'm very pleased to introduce Dr. Meiyin Wu.
Thank you, Heather. I just want to make sure that you can hear me well, as well as see my PowerPoint.
Yes, we can hear you and see your PowerPoint. Thanks.
Thank you. Good morning, everyone. Thank you for having me here, and thanks, Heather, for the introduction. I'm here today to share with you on some case study that we have done in the state of New Jersey. First, I'll briefly go through a little bit about phytoplankton, as most people are familiar with it, so I will go through it very quickly. Phytoplankton is very important for healthy aquatic ecosystems. They are the main source of food for aquatic life. They perform photosynthesis and produce oxygen. At global scale, phytoplankton produce more than 75% of the world's oxygen. Their importance is far beyond just in the water, but for all life on the planet Earth. For management purpose, phytoplankton can be divided into two major groups: cyanobacteria, such as the one on the top, and algae, such as the one at the bottom. And algae group include a wide diversity of groups. Many of them were clearly introduced by Anne and Ken yesterday at the workshop. In a healthy aquatic ecosystem, it is well balanced between cyanobacteria and algae. Algae will keep the cyanobacteria population under control. However, under the influence of global climate change and human-induced eutrophication, the balance is broken. The excess growth of cyanobacteria forms Cyanobacteria harmful algal bloom, or CyanoHop. Researchers around the globe have been documenting more frequent harmful algal bloom at increased duration and magnitude, likely boosted by high nutrients and temperature. This CyanoHop can lead to oxygen depletion, pH fluctuation, and fish kill in water bodies. Additionally, many cyanobacteria can produce cyanotoxins that pose health risks to both human and animals. Starting in 2016, working with the New Jersey Department of Environmental Protection, or NJDEP, my group began to survey water bodies in New Jersey with a goal to document New Jersey phytoplankton occurrence and distribution. Today, we survey a total of 113 water bodies in New Jersey and documented 110 phytoplankton genera. The highest taxa group in New Jersey is the green algae, followed by Cyanobacteria and diatom. Among the 110 genera of phytoplankton, 32 or 30% were Cyanobacteria. This slide includes the 12 most frequently seen and widely distributed phytoplankton genera that we found in New Jersey. Cyanobacteria synechococcus is the most frequently found, followed by the green algae Chlorella. Among the 12 most commonly found genera, 6 are Cyanobacteria, and they are highlighted in blue on this slide. This slide lists the 12 most frequently seen and widely distributed cyanobacteria taxa in New Jersey. Most are common taxa in water bodies of the Northeast, including potentially toxin-producing taxa such as Dolichospermum, Microcystis, Aphanizomenon, and Plantothrax. From our study, in New Jersey, the average phytoplankton cell density was about 180,000 cells per mil, ranging from over 11 million to as few as 300 cells per mil. The average phytoplankton taxa richness was 10, ranging from 36 to 1. The average cyanobacteria taxa richness was with ranging from 12 to 1. The average cyanobacteria relative abundance was 65%. Sadly, we also found waters with 100% cyanobacteria in multiple occasions, such as those that's listed here with dates that the sample were collected. About 66% of samples were found to be dominated by cyanobacteria, which was determined by greater than 50% of cyanobacteria in the water. 28% of samples included greater than 40,000 cells per mil of cyanobacteria, and 22% with greater than 80,000 cells per mil. For folks that are not familiar with New Jersey's cyano-hub threshold, you might be wondering why I'm using those two numbers. Those two cell density were used because they are the threshold established by NJDEP. In New Jersey, cyano-hub alert system is a 5-tier system based on cyanobacteria cell density and cyanotoxin levels. The 5 levels are watch, alert, advisory, warning, and danger. At different alert level, advisory is placed to alert residents of their health risk, and when necessary, advise against recreation activities such as swimming, boating, and fishing. NJDEP has a website dedicated to cyano-hub management. Lake managers and residents are encouraged to visit the website, which includes an interactive map to learn the whereabouts of any ongoing cyano-hubs and to report a suspicious hub event. In summer 2019, several major lakes in New Jersey were found to experience cyano-hub. Greenwood Lake was one of them. Greenwood Lake is a bi-state lake, as you can see on the map. The northern half of the lake is situated in New York, and the southern half of the lake in New Jersey. The invisible state line is in the middle of the lake, so the management of the lake fell under guidelines and regulation of the two states. Greenwood Lake is a popular vacation destination for water sports, fishing, and boating. Cyano-hub prompted beach closure and advisories warning individuals against swimming, fishing, or boating during the peak recreation summer season. The banning of recreational activity subsequently damaged local economies, frustrated business owners and local residents. Several public meetings were organized. Residents and business owners complained about poor communication from government agencies and demand a solution to resolve the problem. On top of that, the two states have different monitoring methodology and thresholds for advisories. While New York relies on visual assessment and at the time of the study did not have any advisory in place to ban recreational activity in the New York portion of the lake, New Jersey, based on cyanobacteria cell counts and cyanotoxin level, advised against recreation activity at the time, and consequently shut down local beaches and advised residents against boating and swimming. The discrepancy in monitoring methods, threshold, and advisories from the two states greatly confused local residents and raised many questions, including this one on the slide. Can algae flow from New Jersey to New York in this lake? Upon the request of the bi-state Greenwood Lake Environmental Commission, my group performed a cyano-hub response study. This slide is showing the results of the northern part of the lake, or the New York end of the Greenwood Lake. We transformed the result into a color-coded system to help the locals better understand the assessment results. The results prove that algae do not follow the state residency requirement. Cyanobacteria do flow and were present at both sides of the state line. While there was no state advisory, the New York end of the Greenwood Lake was also experiencing a cyano-hub at the time of the study. This slide is showing the center of the lake, or the area around the state line. As you can see, there is a state line in the middle. This area is also the deeper part of the lake, which was found to house lower densities of cyanobacteria. The southern end of the New Jersey end of the lake was clearly experiencing a more severe harmful algal bloom. We then held a public meeting to share our results to the residents of the lake from both states. Using both New Jersey and the World Health Organization criteria, it was clear that this bi-state lake was going through a cyanobacteria harmful algal bloom event at both New York and New Jersey end of the lake. Although the two states might not adopt the same methodology and threshold for advisories, the residents commonly travel to waters of the other state and were exposed under the same risk of cyanohops. Greenwood Lake is not the only multi-state lake in the nation. Communications and coordination for cases such as this are extremely important in order to better educate the residents to understand the health risk posed by cyanohop. In addition to interfering with recreational use, harmful algal blooms also adversely affect drinking water sources. Many larger water bodies and reservoirs in New Jersey are used as drinking water supplies for millions of residents. Harmful algal blooms are putting water suppliers at risk of losing their water sources. This next case study that I'd like to introduce is cyanohop management at the New Jersey drinking water reservoir. The Manasquan Reservoir provides drinking water to over 300,000 residents in New Jersey. The reservoir itself is about 770 acres, with additional 1,200 acres of parkland for recreation. So it's a popular recreation destination for many local residents as well. For the past 2 decades, the reservoir has experienced cyanohops repeatedly, which triggered concern from both residents and water users for both drinking and recreation water safety. Oops, sorry. From 2000 to 2010, the reservoir was treated either once or twice during the summer with copper sulfate. Later, the lake was found to have a lower abundance of zooplankton populations. Hence, the reservoir was not treated between 2011 to 2018. The copper sulfate treatment was resumed in 2019 and again in 2020. The objective of this study is to monitor water quality and phytoplankton community during the copper sulfate treatment at the Manasquan Reservoir in August 2020 and to evaluate the efficacy of copper sulfate treatment for cyanohop management. And on the map is showing the study site that were used in this study. We monitor water temperature, pH, dissolved oxygen, fluorescence of phycocyanin, fluorescence of chlorophyll, and study phytoplankton community assemblages. Phytoplankton cell viability was determined using Cytox green nucleic acid stain under a fluorescence microscope. So as you can see on the picture on the slide, the cell will show the color red or color green to indicate the viability. Additionally, for cyanotoxins, microcystin, centrospermopsin, endotoxin, and saxitoxin were quantified using the ELISA method. Here today, I will be talking about phytoplankton community changes as a result of the copper sulfate treatment. The phytoplankton cell viability declined in response to the copper sulfate treatment. One day prior to the copper sulfate treatment, the phytoplankton cell viability was about 62%. One day post-treatment, the cell viability dropped to about 7%. Copper sulfate treatment successfully terminated majority of the living phytoplankton cell, dropping all the way from 62 to 7% in average. However, by day 7 post-treatment, the viability had recovered and reached about 50%. Zooming into the cyanobacteria data, prior to the copper sulfate treatment, cyanobacteria cell density averaged about 9,500 cells per mil and dominated by Crococcus, Dolichospermum, Pentathrax, Cyanococcus, and Uronicinia. The copper sulfate treatment successfully eradicated a large portion of cyanobacteria. 1 day post-treatment, cyanobacteria population declined by 88%. The population quickly bounced back with an average growth rate of 2,500% from day 4 to day 7 post-treatment. By day 7, cyano cell count averaged about 15,000 cells per mil, which was 58% more than the pre-treatment cell density. Copper sulfate treatment not only changed phytoplankton population densities, but also the community structure. Prior to the treatment, cyanobacteria was the dominant group in the reservoir, with a relative abundance of 71%. 7 days post-treatment, the community shifted from a cyanobacteria-dominated community to a green algae-dominated community with only 29% of cyanobacteria.
Oh, 5 minutes left.
In recent years, we documented the results of this study suggested that copper sulfate treatment is an effective, relatively short-term hot management option. Cyanobacteria cells were found to bounce back within 7 days. By day 7, the reservoir was with a higher phytoplankton densities, dominated by the green algae. In recent years, we documented more abundant and severe cyanohub in New Jersey. Cyanohub not only interfere with human recreation activities, but also pose threats to water suppliers and increase the cost of water treatment. Currently in New Jersey, there is a lack of sufficient guidance and threshold for drinking water surveyors, as well as lack of sufficient communication and coordination while managing multi-state water bodies. I can't emphasize enough the importance of communication. New Jersey really has to step up the game and better educate the residents to understand the health risks posed by cyanobacteria harmful algal bloom. Last, I'd like to invite you to 2 student poster presentations immediately following this session, and there will be more case studies on cyanohub and management in New Jersey. I'd like to thank the funding agency for this 3 case study, NJDEP, Greenwood Lake Environmental Commission, and the New Jersey Water Supply Authority. I also want to thank my collaborators and team members. They really are the ones who did all the work, including Heather. So thank you all for being here today, and I'll be happy to take any question.